Hey everybody, so here we are. In this last video, what we did was we used our fragment shader to draw for different parts of this screen according to a formula that we're providing. Draw a different color for different pixels, and this is tremendously powerful. And in the next couple of videos, we're going to be using this to create that noisy pattern that we are seeing. In the first video and at that demo site. We're going to start by bringing in a different uniform, which we're going to call, and it's going to be a float called uTime. And we're going to use this value to animate this color change. So we need to go back and bring this uniform in our index.js. And so we'll say uTime, but uTime is going to be equal to a function. Now, in order to get this function is going to be coming from REGL, and it's going to be a time value. Right now, we don't have access to a time value because we're just calling this function once. But if we put this inside of a regl.frame method, then if you remember from a few videos ago, this regl.frame method is sort of like the draw loop. And in this regl.frame, we have access to a thing called context. And that overall REGL context is really the tremendous power of REGL, the REGL library, for helping us handle the WebGL API. And we're going to bring that value into our function, and we're going to pull just one thing off of it, which is called context.time. Before we look at that, let's console.log here in our frame. First of all, the context, and then context.time. And so if I run those and I look in here, you can see I'm getting these two values, and each time I'm getting a tick value, a time value, a viewport, a view height, frame buffer width, and some other stuff too. So all this stuff makes up the context, and we'll look at all this stuff in future videos. But for now, what we're going to pull off is just context.time. And that context.time, as you can see, is going to be a float. And that float's going to come into our fragment shader as this variable uTime. Let's get rid of these console.logs, because those can get expensive. And we can see now we're getting just a blue screen. And that's because when we add this frame, we change the coordinate space of our fragment shader. So now I'm going to take this out, and we'll just say uv.x, and we can see we get nothing. There's our green, and there's our gradient back. But what we want to do instead is set this value to sine of uTime. So if you remember from some P5 land, a sine function is going to return a number between -1 and 1. And so again, what we need to do is say +1 divided by 2. Making sure that those are all floats, because if they're not all floats, that's going to create a math problem. And so now we get this smoothly animating color change that's changing from one color to the other color as the time value increases. If we want to increase this value, oops, right? We can make this pulse more quickly. We can make it pulse more slowly. And we can also add our uv.x in there. Or we can make this slightly more recursive and add both values in there. And now we're getting this, you know, interestingly weird pattern. And getting control of these interestingly weird mathematical patterns is a huge part of what working with shader language is all about. And I hope you'll find it as fun as I do. It's so hard, but so intriguing and fun. And you can see this is, and let's just multiply this a bit, make it even crazier. Oh, maybe that's not going to work because it's not a float. And so now we've got this pattern happening a little more quickly, and yeah, you can see it's creating some interesting kinds of noise in there. So in the next video, what I want to do is look at these interesting patterns of noise and learn how to shape them. Maybe in the next couple of videos, learn how to shape them a little more effectively.